Okay, welcome everyone to my first ever live stream. Hopefully we're going to start building a game from scratch in C, and I'm going to show the whole process, and we're going to learn a lot and hopefully have a lot of fun too. Okay, so first of all I'm going to give you a little context as to what we're building, why we're building, and how we're building. It all started when I released my first big commercial game called Ilios's Hunt. We released it for PS4 and PC on 2017. And it was a great deal of work. It was like 3.5 years of development, and it changed me completely by the end of the development. And it was great because I learned a lot. Because by the end, actually, because I started just hacking a little bit of scripts together. I used Unreal Engine, so I used mostly visual programming. So by the end, I realized that I actually didn't know how to program. And in order to release the game robustly on PS4 and PC, I had to go down there and do some low-level stuff like integrating the SDK for the consoles with Fmod that we used for the sound library, as well as Unreal versions and all that stuff. So I realized that I didn't actually know what I was doing in terms of programming. But we released the game, and that was really hard, but we did it. And so when we did finally release, I was like, okay, I think I'm going to take a step back and actually learn programming for real. And I used a lot of YouTube videos and Twitch streams to learn, mostly from people who have been doing it for a long time, like Jonathan Blow and Casey Muratori. And I was very grateful for that opportunity. And then I started building smaller projects in C++, things like that. And until I started going back to Unreal and started using that programming experience to build more robust things in Unreal using C++. I built a game, a turn-based game with a level editor, a monster editor, a skill editor. And then I started coming across all these problems that people usually talk about when they say C++, that it's a complicated and messy language, and all the friction that comes with it, like long time to compile, and weird bugs, like even with incremental builds, sometimes things don't work. And with Unreal, I have to build, I have to use the debug editor to see where everything crashes and stuff. And it takes a long time to start up, and it's not a very fun process. So at that time, approximately, when I was getting deeper into programming, games programming, I had the opportunity to have an investment on a startup, which had nothing to do with games. So I was like, I took the chance and started working on that. So I was like, okay, so I'm going to take a break as a professional game developer, let's say, and focus on games as a hobby. So at that time, I started to program, with no engines to really learn and start having fun. And that's why I found the C programming language more interesting. And you can see on my itch.io page, small games I built, those three here on top, with this idea in mind. Taking I even open sourced one of them, which is like a simple Pong. And then I released this new one, which was pretty recently, which built upon the idea of Pong, but making it a lot more fun, hopefully. And so that was the challenge. Making it as a hobby, I decided to go deeper into the programming as well as the design. So it's trying crazy things like that. So I think now I'm going to do one step further than that and actually do a more complex game than I did with Pong. So we have like a lower benchmark, which is what I did in that case. And we can build on top of that. On top, I mean, we can build, we can do a new game based on the skills I learned. Okay, so I'm going to show you the game for a little bit. Okay, so the idea is that you play with both hands. You control them with both hands, and the goal is to not let the ball score a goal. So it's kind of the opposite of the normal goal. And then the game modes change. As you can see in this mode, I'm getting closer to one another, so I have less time to react. Okay. So that was the spirit of the game. I took Pong and then did a lot of different game modes based on that. Okay, let me see if I can get this decent score here. And if I catch like balls with a lot of movement and velocity, it's actually I score more points. Okay, this one's kind of tricky. Okay, I kind of stuck here in the bottom, which is good, I suppose. I only have to worry about one thing at a time. Okay. And you can kind of control the direction of the ball based on your speed. Okay, this one is tricky. Inverted controls. Okay, so as you can see, it's a simple game, but it was built all using C, and we're going to, you know, kind of base our ideas upon that as a minimum level. But I think you can experiment with more things like bitmaps, and this uses like async audio, and that was pretty cool. So we're going to build, so this is kind of the idea that we're going to build, but more complex in terms of design and in terms of programming. Okay, yeah, I think I'm going to lose now. Yeah, I just lost. I had to let one ball go through. Okay, so if you found that interesting, you can download it for free on itch.io and check it out. Okay. Okay, so that's what we're building. So we're going to build a breakout-like kind of game. We're gonna, like we started with Pong and then built upon that in game design ideas. We're gonna do that same with breakout. We're gonna start with a breakout clone. Then we're gonna do some pretty interesting game design things, I think. Okay, but why are we doing this? Okay, so you kind of got the idea from what I told, but to make it more explicit, we have 3 goals in mind. The first one is for me to learn more things about programming and game programming, and so I'm going to challenge myself to do more interesting things. And the second goal is for you guys to learn, because I was very grateful, that I could learn with so much things, through the internet. But most of the things I learned is kind of a very, complicated things in terms of it was hard to get started. That was the main point. So I'm going to do a simpler game, and it's going to be easier for you to get along, even if you don't understand like a lot of programming. Although this is not going to be a tutorial per se. This is just going to be me, programming and talking about what and why I'm doing the things I'm doing. And the final goal is to have fun. And all of the decisions actually that we take is going to be based off these goals. For example, why are we going to do? We're going to use the C programming language as opposed to like C++ or something like that. Well, because I think C is more fun than C++. As simple as that. Because C++ is really complicated, I think, and yeah, I really got along with C, so that's what we're going to use. Another thing that you can think about is why aren't we using a game engine if it's going to be easier to build a game like that? And that goes pretty much through all the 3 points. It's way better to learn by building yourself the whole game and engine, so you understand the whole process. I've built games with most engines, commercial engines like that, and it's really a different process. When you're building with a game engine, you're mostly searching for solutions that people already came up with for specific problems. Like, oh, how do I do that in this engine and things like that? How do they want me to do it, right? But in this case, it's actually we come up with the solutions to the problems that we come up with in terms of design. So I think you have more freedom in this sense. So you're going to learn a lot more. And it's also a lot more fun. So you're going to be constrained by your skills, and we're going to try to improve that. Okay, so that is the what and why we're doing. The how we're going to do it. So I have the Visual Studio compiler installed. I'm using Windows here. So in this command prompt, you can see that I initialized the Visual Studio developer command prompt. So I can use CL, which is the compiler. We're going to compile it using that. And I'm going to use ForCoder as a text editor, but you can use whatever you want if you want to follow along, things like that. Okay, and the basic idea that we're going to do, let me just pull over Paint here just so we can draw some ideas. Okay, so first thing we're going to do is a platform layer, and it's going to be Win32. Okay, we're going to do this simple things like we're going to do the window, we're going to do the input, we're going to do the rendering, just for us to have a playground to experiment with the gameplay, which is the first part. We're going to experiment with the gameplay. We're going to build the breakout clone and then start doing some semantic compression, see what works. And you're going to see that's a very open kind of development. I'm not going to do like very top-down. I'm going to just play around with it and see what is interesting in terms of programming and in terms of design. So after we play around a bit with the gameplay, we're going to do a more robust engine pass. So we're going to start doing bitmaps and audio and things like that, multi-threading things, just to make sure that all the ideas that come up when we experiment with the gameplay will be able to be expressed through the game engine. And then we're going to do a more gameplay. We're going to do a more focused gameplay stage at this point. We're going to create levels, different levels. You see that I have a lot of ideas, and maybe you guys will be able to come up with ideas too. And then at the end, we're going to do a polished pass to publish the game. So if you download the other game that I said as a benchmark, the two-handed pong on itch.io, you can go at zaydan.itch.io. You see that's a single executable, and I put all the songs inside that executable. It was compressed using Vorbis, .ogg and things like that. And yeah, all that stuff we're going to do in the polish pass, which will be able to, do like an asset cooker and do a profiler to see where we can optimize. And yeah, that's the basic idea. So now we're going to start doing the platform basic layer with window input and rendering things. Okay, so first of all, I'm going to create a directory. I'm going to call this breakout, just to be easy to remember. Breakout, and then I'm going to I created an empty repository here, svn. I'm gonna check out that repository. Let me just get the link here. 1 second. And you guys will be able to download the source code too. I'm going to create a itch.io page for this game, and I'm going to post each stream. I'm going to post the progress, so you guys will be able to download and follow along and add to the game and have fun too, programming. Okay, so I have here an empty repository, and now let's start building. I'm going to open forcoder with the breakout. I'm going to create actually another folder. I'm going to create a code folder. I usually do that. Okay. Breakout code. Okay, I'm going to create a Win32 platform, because the way I usually structure a platform is basically the way Casey Muratori taught, which is the game as a service to the platform layer. So the platform is going to do whatever it wants, and then call the game like to update and render. That's it. Okay, so the first thing we're going to do is just to make sure that the compilation works and everything's smooth. We're going to do a simple hello world program. I'm going to do actually a hello sailor. Sailor. Okay. Okay, and how I'm going to do this? So I'm going to use the CL command line prompt, but instead of typing it all the time, I'm going to create a batch file. And if I call this batch file build.bat here in the forcoder, I can call it by pressing Alt-M. So I'm going to do like CL Win32 platform. That's it. So this is the very basic thing. Okay, so if I do that, you see that I created the file, and if I go here inside the code folder, it created the executable and the object file. But I'm going to organize this a little bit better. I'm going to turn off all these messages and pass the no logo flag and the debugging flag to it. Okay, so this is the basic things that we're going to do. After we're going to drop everything in the build folder too. Maybe I can do this. I'm going to create a build folder here too. And then I'm going to push the director for the build folder. And at the end, I'm going to pop the directory. Okay, we're going to go back inside code. So this way, all the build files will go inside the build folder. Push directory. Okay, I have to go back a folder. Okay, that's it. So now inside the build folder, I have the executable. So if I try to run, I have the hello sailor. Okay, so this is the basic setup we're going to do. And now we're going to start actually building the game. So to build a window in Windows, we're going to use a couple things. First of all, I'm going to search for MSDN WinMain, because we don't use main when we're doing graphical applications inside of Windows. We use WinMain, which is this call like here. So I'm going to remove the main. Also going to remove the stdio and do the windows.h. Okay, so this is the entry point of our application. Okay. Okay. Okay, we can fix that later. Okay. And let me see if it compiles. Okay, looking good. And the call we want to do to create a window is create window ex in MSDN. Okay, so this is the basic thing we want to do to create a window, and returns a window handle. Alright? And I'm going to try not to copy a lot of code from my previous project, just so you guys can follow along a little bit better. Maybe at the end when we get to more complicated things, I'll do it. But at the beginning, I think it's nice to do it by hand. So it's going to take a little bit longer than it used to. If you guys have like a reference project, it's also easier. Okay, so I'm going to create a window, and this is the things that it's asking. Asking for extended window styles, and I think we don't need any of that in terms of extended window style. And a class name. Okay, so that's the thing. Before creating a window, we have to create a window class. That's how Windows structure things. So we're going to create and register a window class. All right. So this is it. We're going to register class, and we're going to pass a wind class a. Okay, window class, and let's see what this structure is made up of. A lot of stuff actually, but most of it's going to be 0, so I'm going to initialize it to 0. Okay, the style, window class dot style. Let's see our options. Class styles, oh, it's right there. Okay. Yes, we're gonna have to do at least, yeah, we're gonna do H redraw, stands for horizontal redraw, and we're going to do vertical redraw, because we're going to do the other painting by ourselves. We're going to do software rendering for this project because it's simple enough, it's educational, and it's a lot of fun. It's a lot more fun to debug software rendering, where you can see exactly everything that you're doing, and instead of hardware rendering, which is more complicated. Okay, so this is what we need in terms of style. Okay, class name. The class name is what we have to pass to the window, to the create window. Okay, so it's called LP class name. I'm gonna call this game window class. Okay, and we can pass the class name now down here too. Okay, the window name. Okay, no, I'm back to the. Sorry, I'm confused. Okay. This is it. We don't. Okay, we have the window procedure, because the way it works on Windows is that we have callbacks all the time for the window messages. So the window class, we have to create a procedure specified like this. Okay, and this procedure, we're gonna pass it as a pointer here, and this is going to receive all the messages, the main messages. We can also peek message. I'm going to do that for input, but we have to do this. Okay, so I'm going to create a procedure. I'm going to call this window callback. Okay. Okay, and let's just see how we're doing in terms of compiling, just to make sure that we don't have a lot of a redefinition. Yeah, I'm going to return def window proc a, which is what we have to do to few arguments for a call. We have an example here, if I'm not mistaken, of a window proc. Yeah, I think we got it wrong. We copied from the wrong place. This is the window procedure that we want to do. Okay. Yes. Window callback, and it has all these parameters. Okay. 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 And then we're going to do, as a default, we're going to call the default Windows procedure. That's going to make it maximize properly, and all that stuff without us having to worry too much. So we're going to pass, all the 4 things that we receive here. So we're going to press the window, the message, the W param, and the L param. I'm going to rename those just to be a little bit easier for me. Window, message, W param, and L param. Okay. And let's see where we're at. Yeah, so we got the name wrong because we copied from the wrong place. This is the correct name for the class name in the window procedure. Okay. Yep. And then we're going to do here as well. Okay, so now we're specifying the window class that it wants us to do. Okay, and it has a linker error because we have to do user32.lib, the linker. Okay. Okay, so we're progressing. Let's go back and see what we're missing in the window class structure. Okay, extra instance. I think all these can be 0. Yep. I'm gonna try doing all this, just this for to start with. All right. Okay, then we're going to register the class. We're going to pass this the window class, the pointer. Okay, and then we're going to finish our create window. Window name. We're going to call this breakout for now. Maybe we're going to come up with a more interesting name later on. Okay, style. This style is always tricky because we have to call at least the visible style, at least. And I'm also going to do the overlapped window, if I'm not mistaken. Overlapped window, yeah. Overlapped window. And okay. Let's see what else. XY and width and height. XY, I'm going to do the default. If I'm not mistaken, it's the CW use default. So Windows will see the best place for it. I'm going to do 1280 by 720 for now. Then we can do full screen later when you do the other pass. Window parent, no menu. Instance, I don't think we need any of that. So it's going to be 0, 0, 0, 0. Okay, let's see what we have. I'm going to try launching the build. Okay, and yeah, you guys can see, right? There's a window. It's popping up really fast. That's what we wanted for the time we created the window. It's not much code, and it's like the first time we're doing this, right? Because I could have copied it from another place. And okay, so that's a start. Now we're going to loop forever, basically. I'm going to create a global variable. It's going to be a static int running. Actually, what I'm going to do is I'm going to define like true and false, just so it's easy. And then we can type def, bool and stuff. I'm going to type def int and call it b32 for boolean. So we can also do a define for static, because static doesn't mean much to me. So I like to define, you know, global variable and static, and also do a like internal for whenever we were using internal functions like static functions, because we're going to do a unity build. We're going to build everything in this file, so it's way easier and less complicated. Okay, so now it's a global variable running, and the default is false. Actually, the default is true, right? Okay, true macro redefinition. Does Windows have a true already? I'm gonna drop Windows all the way down here so that it doesn't. I'm also going to pass. I think it's LC. No, it's not LC. It's LD. No, I'm going to cheat now. I'm going to see in the Pong's code compiler flag, because if I don't pass the full path here, I can actually just copy this reference that I usually use. It's pretty useful. It's just a comment of the most common compiler flags, and okay, it's FC, full path on errors. So see that the path is just relative, so forcoder doesn't understand that. If I pass FC here, now I can definitely see that this is a problem. And just because I was a typo, had nothing to do with Windows. Okay, expected to follow. Ooh. Okay, because there's semicolon here. Okay, now we're going to do a while running. And this is the main loop of the program. So that basic thing of input, simulation, and render that games are structured, that's what we're going to do. For input, we're going to create a message, and we're going to call peak message A, which is good because we opened the WinUser.h, so we can do like autocomplete on Windows functions. I'm going to do peak message, and I don't remember what it requires, so I'm going to search the documentation of MSDN for peak message. Okay, let's see. The message has a pointer, the window, and filters. I don't think we need any filters. Both 0. Yeah, that's what I'm going to do, and then I'm going to remove the message. So I'm going to pass the pointer to the message, the window, 0, 0, and remove. Okay. Yes. So that's the idea. So for every message, we're going to see its type, right? So we can do a switch. Actually, we don't actually need to do anything here for now, except pass it as pass it to here, to the callback, if we don't manually do it. We're going to use the translate message, A, right? I think we passed the message. And yeah, let's see if there's an example here. Yeah, there's the example message queue. Yeah, dispatch message. Dispatch. Those are the two functions. So this is the basic thing. We're going to peek or get message, right? And then we're going to do the input here in order to get with all the callback. And here we're going to do the translate and dispatch message. Okay. So all the messages are coming through here. Okay. So now we can treat them. We're going to do a switch on the message, and in case it's like a WM close or a WM destroy, we are going to set running to false. Okay. And then I can actually create a result here. Can I do this as an internal? Maybe. Which means a static. Result's going to be 0. And then the default case is going to be this one. Okay, and then we return result. Okay, looks good. Now we should be able to actually close the window, make it full screen, all that stuff, because we're going to keep reading the messages in the main loop, in the infinite loop. And here, the close and destroy message will actually stop the game from running. Going to turn the running to false, and then it's going to stop. That's the basic idea. Let's see what happens when we try to run the game. Okay, so we have the window. We can move it all right. We can make it full screen. We can change the size, minimize it, and close. Okay, and if we go see the process in the task manager, it is not running. Okay, so this is the basic thing we need for a window to pop up. Now we have everything we need to get started in the game. So window is done. Now we need to render to that window. Okay, and we could create an OpenGL context and all that stuff, but we're gonna do, at least for now, software rendering. If the games get a little bit more complex, we can do hardware rendering later through OpenGL or DirectX. But for now, all we have to do is get a buffer. Let me type for you guys to understand. So this is what we need. We need a buffer, which is basically some memory that we can draw to. Okay, so this is the Windows part. It's going to give us the memory, and the draw part is up to us, up to the game. So we can do like pixel independent drawing, or you can change based on the screen, and we're going to do all that stuff. Okay, that's the buffer that we need for the memory. And then we need to say to Windows, use the buffer, like draw to the screen. And this use the buffer, we can use like the stretch the bits call, which is our starting point in order to look at the documentation. And that's the rendering. All right, so let's go here. I'm going to see this documentation for stretch the bits. And if you guys have any question, can just I'm looking at the chat here, so you guys can ask any question, and hopefully I'll be able to answer them. Let me just see here if I can see the chat properly and not. I think I can see it. Yeah. Okay. So this is the call we're going to use to tell Windows to use our memory and put it on the screen, right? And there's a lot of stuff, but you can see that's not. It's pretty common things. Okay, so the first thing we need, it's called an HDC. It's a handle to a device context. So the way Windows work in terms of drawing using the old libraries, like GDI and things like that, it uses device context to reference to what I'm going to draw to. We just created a window here, so we can do a get DC to get the device context of that window, and we can save it in a variable handle to a device context. Now, this we should only do it once because we only have one window. So if we pass that here, we shouldn't need to do any more work. I'm going to leave 0 that for now, just to make sure that I'm compiling. Hey, I see a lot of new people in the chat. Nice. I'm going to do an end if here. Okay, so see, so I got the device context here, which is the reference that we need for Windows to tell it, okay, use this to draw in this window. Okay, so that's the device context. The destination X and Y is going to be 0 and 0, and the destination width and height, we're going to have to save that, because the user can change the size of the screen, right? So we're going to have to say, I'm going to call this width and height for now, but we're going to do a little bit more structured thing. As well as the source X and source Y. We're going to do a straight copy to the buffer, so we're going to keep the buffer exactly the size we need. We're not going to do like a off-screen buffer with a different size and then downscale, things like that, at least for now. Because we want to just get started. The focus is the gameplay, right? So we have to do the minimum to get it up and running. Okay, so that was the source and height. This is the pixels. Remember when I told you that we need the memory and give that memory to Windows? This is the memory. I'm going to call this memory. And then it needs a bitmap info. And that's the little bit of the not so fun part. If I go to the documentation and go to the bitmap info, we have to fill this struct which has an info map, bitmap info header, and then we have to fill all the stuff with the size, and then we have to do the planes and compression and what kind of color we use. That's the more the more elbow grease part. Okay, so let's assume we have a bitmap info here. All right, and the usage of the stretch DI bits. Okay, specifies whether. Okay, yeah, the usage is RGB colors. Yeah, I was confused there for a moment. And now we have the final thing is what are we going to do with that buffer? We want, we can see the rest of operations that it has for us. We want to do a copy, right? A source copy. We're going to copy from the source, which is what we're going to give in the bitmap memory, to the actual buffer that Windows uses to put things on the screen. Then it's going to send to the video card and all that stuff. Okay, so that's the basic idea. Now I have to fill all those variables, right? Right. And I'm going to create empty ones just to see if we compile. We're going to create a width and height here. And then we have to create a memory. And we have to create a bitmap info. Okay. Yes. We can take out that int. Cannot convert. Okay, yeah, we passed as a pointer to a bitmap info. Okay, that's it. And we also have to tell the linker. We have to tell the linker to use the GDI 32.lib. This lib is the one that we use for these kinds of operation, for software kind of operations in terms of rendering. Okay, and just since we open the build here, I'm going to copy this. If there's no build directory, create a build directory and delete all the old PDBs and stuff, because I think it's way better to have the system to create the directory instead of have to manually do this. And we're going to delete the files that we don't need, like this temp that we get this information from, and the object file. And then later we can do more things like say incremental no, and don't put like unused things in the executable. But we're going to do that one step at a time. Okay. And now I have to fill those. Since all those refer to our buffer, to our, let's say, rendering buffer, I'm going to create a struct for that. So I'm going to call this a render buffer. It's going to have a width and a height, and then it's going to have a memory. I'm going to do as a unsigned 32-bit pointer. I'm going to call this pixels. We're going to have to create these types here in a moment. And we have the bitmap info. Okay, and since we just created all these type depths, I'm also going to include std int.h, I believe that's so. Yes. And then I'm going to do type def. I believe it's int 32 underscore t, if I'm not mistaken. Put a semicolon here. Yes, okay. So I'm going to do a unsigned 2. Now let's see if the problems, okay, the problems are solved. So I'm going to just quickly do all the rest. I'm going to do the 8-bit. Okay, let's 32 8-bit. This is going to be 16-bit, 32, and this is going to be the 64-bit. Okay, and actually this thing I'm going to make our first actually file called utils for utilities.c, just so we can organize it a little bit. So if we do like multi-platform things, this part of the code can be used for all the platforms. We don't have to keep this in the Windows specific file. Okay. Okay. Now we're going to create, for now at least, as a global variable, our render buffer. I'll call this render buffer. Okay. And then we're going to do the render buffer dot width, and the same things for the height. And the memory, we call it pixels, and the bitmap info too. Okay. Okay, bitmap info. I think I just call it bitmap info with no underscore. No, let's see. I just call it bitmap. Okay, now I'm gonna go back with the underscore. Okay. See, performing full link. This is the things that we should improve in the build.bat, because since we're doing a Unity build, we can pass to the linker the incremental no flag. Let's see. I have to pass link linker. Let me cheat and see how I set up the linker flags. Incremental. Yeah. Oh, okay, I have to pass before the libs. Link. Okay, that's it. I'm not sure why it's okay. I have to do the dash. Yes. Okay. Now I'm going to do opt ref2, just like here, to don't put useless things in executable. And the other things we're going to do as time progresses. Okay. Now we are looking good. Now all I have to do is fill this thing with this struct with useful data. And this is in the case of a change in size of the window. And this is cool because this is going to be called when the window is created. So we'll have to initialize these variables elsewhere. We can do everything here. And the basic idea is to get width and height, and then allocate the buffer. And of course, fill the bitmap info. Okay, so these are the three things we need to do here. And now when we pass, should be good to go. I'm not sure what's going to happen if we try to run. Yeah, nothing. I suppose that maybe we should have like a black screen, but we're going to get that in time. Okay? So to get the width and height, I'm going to go back to MSDN. We have to get window rect. Yep. And we just passed the window and a rect pointer. So I'm going to create a rect. Rect. I call this rect. Then I'm going to get window rect, passing the window and the pointer to a rect. Okay, now the rect has a top, left, right, and bottom. So the way we're going to do the width is going to be the rect dot right minus the rect dot left, and the way we're going to do the height is the I don't remember if it's the bottom minus the top or the other way around. Okay, now maybe a good time for us to start debugging our program. So the way I'm going to do this, I'm going to open Visual Studio with devenv, and I'm going to pass the executable as a parameter. Devenv, okay, for development environment, right? And then hopefully we'll be able to just adjust the size of the screen here. Okay. And now we should be able to step through the code with F10. Okay, maybe it's a little too big here. Okay, close. Okay. Nice. And I'm going to put a breakpoint here. So when we create the window, this is called. And then the rect, these are the values. Yeah, it's the bottom minus the top. So the width, can you guys read the tooltip? Maybe a little bit too small. The width is 1280 and the height is 720. So this is the basic setup we need. Okay, so we got the window size, width and height. All right. Now with that, we can allocate the pixels. We're going to have a unsigned 32-bit integer for each pixel. So this is how I'm going to do. If we have already if we have already allocated the pixels previously, we have to free them because they usually resized the window, and then now we can allocate again. Since we don't expect the user to keep changing the size all the time of the window, we can actually do this allocation, even though it's going to be a little bit big depending on the resolution. Hey, Nikolai, yes, we can. I'm not sure the context of what you just said. Maybe I was in doubt of something. Yeah. So to allocate, we could use malloc and free, which are the standard C library things. However, since we are in the Windows layer, I'm going to use the virtual alloc function, which is good for allocating a big chunk of memory, which is exactly what we're going to do. And yeah, this is what we need. We pass the address or not of the memory we need. Remember, that's a virtual memory, right? The size, what type of allocation we're doing, and if we're going to protect that memory or not. So the basic idea is, and it returns the void pointer. So what we're going to do is the render buffer dot pixels equals the virtual allocate. So I'm not going to specify an address. The size is going to be a size of U32 times the width that we just calculated, the render buffer dot width times the render buffer dot height. Okay, so this is the size, and the allocation type. We're going to do both a commit and a reserve, right? Because we're going to commit the memory and start using it. What type of a game are we coding? Okay, so we're going to start as a benchmark. We have this Pong game that I built a couple months ago, and it's a very simple game. Let me just show you. I'm going to show you the screenshots. You can go on itch.io, itch.io, and see. This is the kind of a technical challenge that we're going to face. Maybe a little bit more. We're going to do bitmaps too. But this time around, we're going to start with breakout as a base for game design, and we're going to start creating all these crazy ideas on top of that. Just like this game, I created a lot of crazy ideas on top of Pong. So we're going to do like a breakout clone to start with, and then we're going to do interesting gameplay things. So this is the plan. We're going to do the platform stuff that we're doing. We already did the window, and we're working on the rendering, which is not going to take a lot of time. And then we're going to do the base gameplay, which is the fun part, right? We're going to do the breakout clone and start playing around with some ideas. Yeah, breakout is a pretty interesting game to make. You know, someone just said I made breakout this semester. Breakout is a nice game to program, but the challenge I want to do with this version of breakout is I want to go beyond the you destroy the blocks and things like that, and I'm going to start giving like more behavior to the blocks, like they move certain patterns or some behaviors, and they chase you and things like that. That's the basic gameplay craziness. This is the gameplay craziness. So after we do the basic gameplay, we're going to do a more robustness pass on the engine, making it faster and bitmap support, and making audio and multi-threaded audio and things like that. And then we're going to go back and finish the gameplay with all those crazy ideas that we're going to come up with in terms of making the breakout, which is that simple game that people are used to, but making it more interesting. And then we're going to do the final polish pass. So that's the plan. And I'm going to guess it's going to take like 1 or 2 months of development. This is like my free time, and streaming is my first time streaming. It's going to take a toll in my productivity, but the point is to learn a lot, both you guys and myself, and also have a lot of fun. So that's the point. And yeah, we are finishing the call. We did the strategy bits call, which basically tells Windows that we're going to display that buffer, that pixel buffer, in the screen. Now what we're doing is that we're getting the buffer using virtual alloc. So we're allocating this size of a buffer. And the good thing about virtual alloc, let me go back to the here, is that it also zeroes the memory by default, so we can test like a black screen. Normal, resistance, and bonus block. Yeah, that's the thing. You know, that's the interesting thing about programming and game design that I find most engaging, is that you start out with a simple idea, and then when you start doing it, you come up with more ideas. Like you start doing new blocks, and maybe, well, what if the blocks do different behaviors and things like that. And I think that's the most engaging thing. So we have to, get off the base for us to experiment with the gameplay and then dictate what we're going to do engine-wise, which is a lot of fun. Yeah, it is Handmade Hero 2.0 because Handmade Hero is a lot of, it's pretty much where I learned to program. But the scope of this game is way smaller than Handmade Hero. First of all, because Casey, has been programming for more time than I've been alive, right? So he's a lot more experienced than me, being a professional game developer for a long, long time. So he can take a bigger game as a scope. But this game is going to be really short in terms of programming challenges, just for us to release. And you guys can see the whole process of getting the game, published on itch.io, from the very first line of code that we're doing today to the polish and the gameplay, crazy ideas, and the audio and things like that. So it's like kind of a smaller Handmade Hero, like a Handmade Hero Lite version. And then we can do like bigger projects, 3D and with lighting and all that crazy stuff that Casey's been doing, which is I think that's the biggest compliment Handmade Hero 2.0 you could give me. Okay, so mem reserve and mem commit, and then we're going to I'm not sure we need the protection, right? So let's see the protection. I think it's just like read write. Let's see, read write, execute, read write. Okay, we have page read write. That's what we're gonna do. Okay, let's see if this compiles. Okay, nice. And now, if we do have a buffer already, all we're gonna do is the mem free, the virtual free, passing the pixels. And I don't think there's any more parameters. I do. Oh yeah, actually I do think. Virtual free. Yes. Yeah, I can pass 0 as the size, and then the free type. I can do mem release. Yeah. Okay, so if I pass 0 as the size, it frees the whole block. Okay, so this is the basic thing that we need. Now we're gonna have to fill the bitmap info, and if I'm not mistaken, most of it is not very interesting for us. Let's see. Render buffer dot bitmap info dot header. Let's see exactly. Yeah, BMI header, because that's how it's specified. So it have a long chain of structs inside structs. Okay, the size, we have to pass the size of the bitmap header struct, right? Yeah, it's kind of weird. Just for them to check out the version, so they ask us to do this. Okay. The width and the height we have just calculated. Okay, I'm just going to. The width is going to be the render buffer dot width and the render buffer dot height. Okay, planes. I don't remember if we need planes. Must be set to 1. Okay. Well, if that's the case, I'm gonna set it to 1, I suppose. Bit count. Yes, the number of bits each pixel. Yeah, we're gonna do 4. Actually, I think it's 30. Yeah, I'm sorry, 32 bits. I don't know what I thought there. 32 bits per pixel. That's what we allocated here. That's what we're specifying. Okay. And okay, bit count, compression. We're going to do no compression, which I suppose is RGB8. Okay, and size image. This may be set to 0 if okay. If you see can't be set to 0, just set it to 0. That's basically my rule with Windows documentation. Pers per meter, we don't use that. I'm gonna keep it at 0. Actually, since this is on the global stack, actually I'm gonna call this a global variable. it's already initialized to 0, so I don't need to set it to 0. Right, so control used. I don't think we need that, and the important. Okay, so we're gonna try do that. Bitmap info is not a member of. Oh, we did bitmap underscore info. Okay. Okay. Now I'm not sure what's gonna happen, so we're going to step in the debugger just to make sure that nothing explodes. Okay, so the width and height is as we expected, and we should have no pixel, so we're not going to free. Okay, so if I calculate, yeah, let me just see pixels. Yeah, so we do have a bunch of memory, and it's 0, so we can do all the things we want. So if we display this memory, we expect a black screen at this point. Let's just see what we see. A size of the struct, okay, width, height, planes to 1, big count to 32, compression to BRGB, which is 0, so we could just do nothing. So let's see if we have a black screen. We do have a black screen, and if you change size, it automatically allocates, and the allocates, let me put a breakpoint here. So I'm going to put it full screen. See, so it stopped here, because we do have pixels, so we're going to free the pixels, and then we're going to allocate the new size. As I told you, since we don't really expect the players to keep changing the size of the screen, like at all. We don't care about having to do all that stuff again and allocating things. Okay, so that's it. We have the base for our rendering and our window. Now we should be able to create our own rendering functions to change the color and do pixel things. Now it's going to start being interesting. We're going to exit the Windows part. We're going to create a new file. We're going to call this software rendering.c. And as I told you, we're doing a Unity build, so all the files are included here. So I'm going to include the whole C file. Software rendering.c. And for now, we're going to have a basic function. I'm going to do a internal void clear screen, and I'm going to receive a color. And I'm going to set all the pixels to that color. And so this is the doubt. Maybe we should pass the render buffer as a parameter, like where do we want to render to. However, I think it's going to be better just to have this as a global for the game as well. So this is going to be the Win32 render buffer, and I'm going to create a type def game render buffer that the game is going to access, or not. I'm not sure. Maybe for now I'm just going to comment this like platform non-specific specific part. Okay, and this is the platform specific part. Okay, so we're going to use the render buffer as normal here, as supposing we only have one in the global scope. Okay, did I delete accidentally? Internal void. Yes, I think I did. Let me go back. Yeah, I don't know why I did that. Okay, so I'm just going to recreate it. Render buffer, render buffer. Okay. Now, clear screen. What we're going to do? We are going to get a pixel, right? And we're going to set it to the pixels in the render buffer. And just as a disclaimer, if we find out that this is a bad idea and we should do a little more organized thing, we can. This is not like set in stone. This is the first version. And okay, and now we're going to do a for. We're going to do for each pixel. So let's do a for y first. For y, and y render buffer dot height y plus plus. And the same thing for the x. Okay. Okay. And then we're going to set the pixel to the color and increment the pointer. That's it. That's the only thing we're going to do. Equals 0. Okay, yeah, in this case, we should have the software rendering after the globals. Okay, and now, if we come here in the simulation part and call the clear screen, passing, I don't know, let's do a orange. Hopefully, we'll see an orange screen. Let's see. I'm sorry, that was a yellow screen, and it's not actually working too nicely. You only feel like about a little bit over half the screen. Actually, we're setting a fixed number of pixels. Okay. First of all, let's do it orange, just for fun. And yeah, because you did high twice. Okay. Copy and paste bug. Typical. Okay, now let's see if we have an orange screen. Okay, now you can see the orange screen. And now hopefully you can see that all we need to do now is to do like helper functions to draw, you know, player and pixel dependent things and things like that. We're going to start with just rectangles to do the first gameplay part, you know, and then we can go ahead and do more of a bitmap, more polished thing later on. Okay, I'm going to do a slightly darker shade of orange, just so it's not like super blindly orange. And we're going to create more functions now. We're going to do internal void draw rect. And for now, it's going to be in pixels. So it's going to be draw rect in pixels. We're going to pass, you know, the first position x, the first position y, and then we're going to do the second position x and the second position y. Okay, and the idea is the same thing here. We're going to start. We're going to have a pixel that we will draw. In this case, it's going to be the pixels. I'm going to show you guys what I mean. So let's see, we have a rectangle here that we want to draw, correct? The pointer is here, the pixels pointer, right? And we want to set it to here. How are we going to do that? The x offset, just to add the number of x pixels that we start with. You know, I could also call min x, not sure which one's better. So the pixel is going to start at the min x plus x0. Okay. Now this is the first part, and now the second part is to do the y. Since we're doing a per row movement here, just to end here and then just increment the pixel again, what I'm going to do is I'm going to add the width, which is a render buffer dot width, times the actual y that we're going through. Okay. Color undefined, and we're also going to receive a color. Okay, int color. Actually, U32. Okay. Now, if we should clear the screen and then draw a rectangle in pixels, I'm going to do a 50, 50, 150, 200, and now we're going to do that yellow. Okay, let's see what we have. Okay, we do crash. Let's see, first of all, yeah, actually we did it wrong. We start the pixel correctly, but we have to do the limited number of runs, right? I don't know why I just expected it to work. So it's going to start in the x0 and it's going to end in the x1. Start in the y1 and end in the starting in the y0 and then in y1. Let's see. Okay, now we see our yellow rectangle. Is the position correct? I guess. I mean, starting at 50-50 and going to 150-200. I'm not sure though. I kind of expected it to be the same distance, the start here. are you using a program to code and how to run? Yes, I am using the text editor for Coder. You can download it for free. It's pretty cool on itch.io, even for Coder, itch.io, which I think is a great editor. Very simple to use, and you can buy. There's a paid version. There's also the demo version, which does everything you want. But I am running in the Visual Studio because I know I can debug it here. So I set breakpoints and run and all that stuff. So yeah, I use kind of these two programs, and I do compile here by pressing. I explained it a little bit earlier in the stream. If I press Alt M, I run this batch script. I'm sorry, not this batch script, this one, which basically just set the compiling flag, a couple of compiling flags, and compile the code. So yeah, two programs to program. I like this workflow quite a lot. I'm going to do a 50-50, 100-100 just to make sure that our yellow rectangle is in the correct spot. Yeah, I kind of expected a little bit different approach. I'm going to use paint just to see if I'm completely crazy or not. Hopefully you guys can see that. How many pixels is that? Okay, so in the Y I only have like 14 pixels, and here I have the somewhat 50 pixels. So yeah, not working too well, our code here. So let me just review it quickly. We start off in that specific pixel. Okay. And then, yeah, go to that pixel. I'm going to try like 200, 200, 500, 500. See, now it looks correct. Yeah, I'm also going to clip. We don't have a clamp function yet, so I'm just see if x, y, or we can do a clamp. I'm going to do a clamp function. I'm going to create a math.c file, and I'm going to do a internal. Let's do internal int clamp. Min, say val and max. Okay, so if val is less than min, return min. If val greater than max, return max. Return val. Okay, and then in the windows, I'm going to include math.c. Okay, so I'm going to do this guy equals clamp, and then I'm going to do 0 himself and the width, and then y I'm going to do with the height, and I'm going to do the same thing with the x1 and the y1. Okay, now we shouldn't, we shouldn't crash if we get off the screen. Okay, we are coming along, right? Okay, yeah, I do think it's correct. I'm not sure why putting close here was a problem. We can test it more, calmly later on. Just excited to get things on the screen. Now, what we are going to do is just have a basic input system to be able to control this. I'm going to make it a little bit smaller, right? To be able to control this guy with our keyboard. And then it's going to be more obvious if there's a problem or not. Yeah, I do think there's a problem. With our software rendering. With the Y software rendering, right? Y starts off as a y0 less than y1, y plus plus. And here is the width times the y. Yeah, it does look correct. Yeah. Okay, if you guys do spot the error, make sure to tell me, right? But let's focus on input, which is the last thing we need. We're also going to make this a little bit better before we focus on gameplay. But making input is the kind of the last major thing we need in the first version of the platform layer. Then we can start doing the gameplay. Okay. Input. Now we do have the peak message here, and we can do a switch on the message, I believe. Let's see. Yes. And if the message is a window message of key down, for instance, let's see. Case key down. Let's see if that's it. Okay. But we're also going to test the key up messages, I believe. Okay. And in this case, we don't actually need to run the default messages because we want the input to be processed here and not in the callback. All right. Okay. Now, what are we going to do? We have to get the specifics bit of the message here. Yes, I love forcoder for that, Morpheus. The auto indent is crazy. I've never had to type a tab again, and it's so much more fun to write this way. And it's very smart. I've never had a problem. If we do like if something, and then we want to to do in this line, it also indents the other one. If we want to drop into the other line, it indents the if. If we open the curly brackets. So yes, the auto indent is great, and that's pretty much the main reason I love forcoder. It's called I think he calls it virtual white spacing, things like that, and it works great. And if we do open that in an external editor like Visual Studio, it works. It does have the actual spaces of the indentation. So if people want to program here and have all sorts of hard time, re-indenting things, they can do so. If you have more people in the team and things like that. Yeah, I'm not sure. Maybe someone did that in Vim. I don't know, but it's one of the reasons that I stick with forcoder because that alone, is so much more fun to write. Okay, so yeah, about the window messages that we're going to do. If we do look in the peak message documentation, we're going to see the message type, and then we can extract the input that we're looking for. We have to basically see. I don't remember exactly if it's in the W param of the message, the VK code. Let me see, MSDN VK code. You can also do that. Okay, virtual key codes. Yes. Let's see if there's a reference to where it is used. Okay, virtual key codes and WMS problems. Okay, let's see an example someone did. Yeah, if we're going to see an example, we might as well cheat with our own code. Yeah, I think I'm going to do that just for the sake of it. It's not that interesting anyways. So I'm going to open the POM code. Peak message. Okay, and I also add the system downs and ups for F4 and these other kinds of messages. You can also do that. Okay, so this is the three things I extract from the message. The rest is my own code. I extract the VK code, which is the W param of the message, right? And if the button was down and if it is down at the moment. This is the three things we do need. The rest we're going to write by ourselves. Just for demonstration purposes, if we do peak message here, peak message in MSDN, we should be able to find the message specification, like message type. Yes, message structure. Okay. Yeah, I'm not sure where to follow the documentation to get exactly where this W param got the message from, and all these bits specifically in this bit array, this bit field, right? But the basic idea is now we can see which key was pressed. If it is down at the moment, like the key up or key down, and whether it's released or not. So just for the sake of testing, I'm going to do a Boolean running. We also have running character. I'm going to set it to false, and we're going to do if the VK code equals to VK left, I believe. We're going to do character equals true. We're going to improve on that just to start iterating. Okay. Now, so no character. I'm going to press left, and we do see the character. And now we don't see. We can't turn him off anymore because that's the only thing we do. We just set it to true. Now, if I press the button, I could set it to is down. Yeah, but the auto indent in Vim, if I'm not mistaken, it's different from this virtual white spacing kind of thing. Like it automatically indents the whole thing I'm doing, and it works great actually. Yeah, that's what I told Morpheus. There may be a plugin or a add-on thing like that to Vim. I'm pretty sure there is to make it easier, but I don't know one that does exactly like this. It's kind of a crazy automatic thing with and runs really smoothly too. Okay, so now we're going to set only fits down. Okay, now that's the basic functionality we have. And we can also do things like get the key up and key down. But how are we going to structure this input? Because now we have the basics of we need. We have the input, we have the rendering, and we have the windows, the window, right? And now we're going to improve on that as well. So it's not done for the gameplay, but we are going to do all of them at once, I suppose. So what I am going to do now is, in our folder here, I'm going to create a game.c file. And as I told you in the beginning of the stream, the way I like to structure the platform layer is, even taught by Casey Muratori from Hayman Hero, is that the platform layer, which is our Windows here file, this file, I'm sorry, not this file, this file. This file is the main file we compile and rules the program, let's put it that way. And at a certain point here in the simulation, it calls the game. So the game doesn't worry about creating a window and doing all that stuff, saving the window. And no, all the game wants to do is to get the input and tell the platform layers to draw stuff. So that's what we're going to do. We're going to do the simulate game here. And for now, just as a cheat, we're going to pass the input, in quotes, right, to the game, which is now just this variable we created. And the game can now do the simulate game. We're going to receive the move character. Okay, and if move character, do this. So this is the basic structure. The Windows file can worry all can worry about all this weird Windows stuff, and the game can focus on the gameplay. And I think it's a great way to separate these two parts of the code. And we also have to add the game file. We're going to add after the software rendering. Okay, now we should have the same thing we had before. Okay, we do have. And now what we are going to do is focus on extracting the input more specifically, because we want, maybe we want to use like the mouse for to control the paddle in the breakout game, or maybe we want to do it with WASD or the keys. But the idea is the same. We're going to have a platform common file. This is the specification of what the platform layer uses to interact with the game. For example, we're going to have a input struct, right, that has, for example, the mouse position, mouse X and mouse Y. Okay? We're going to do a little bit of a better job with this in a couple seconds. We're also going to have buttons that the game is going to process. So if you do have a button, I don't know why I typed buffer. Okay, if you do have this button, it's going to have like is down and I'm going to do the trick of saving the half transition count. I'm going to explain this briefly, but the basic idea is we're going to know whether or not it was pressed or it keeps using down, or if it's just down, by using how many transitions, or half transition, right, which is from up to down or from down to up, it had on this frame. So if the user presses like the button really fast and in one frame he does like an up and down, we can see that he processed down, but he did up in that frame. We can do all sorts of crazy things, but I don't know we're going to get to do that. We could just save a boolean like changed, things like that, if we want to do a more simple version first, which I think is wise. Okay, and I'm also going to do an enum. I'm going to, it's going to be an anonymous enum. I'm going to call this like button left, button right, up and down. Okay, and I'm also going to do the button count, so I can here create a button array. If I can type button. Oh my god. Button, buttons. Okay, button count. Okay. So this is the basic idea. Now the game will receive this input and be able to process it as it needs. So instead of creating all this character thing, we're going to create an input. Okay. And here, if the character is down, I'm going to input dot buttons in button left. Dot is down. Okay. It's going to be equal to is down. And the half transition count is going to be, oh, I didn't put that, I just put the changed. I'm going to set changed to true. Okay. So this is the basic idea of the, we can do like a macro here just to type less. But that's the basic idea of our input. And we're going to try and see if the game can process that. Okay. I'm also going to import that platform common .c file character, and I'm going to pass a pointer to the input, and then in the game we're going to be a pointer to the input, and then here I'm going to test if we're also going to have macros to type less here, but the idea if input buttons button left dot is down. Okay, let's see if we get the functionality back. Yes, the difference is it already started is down true for some reason. If is down. I'm not sure because, okay, yeah, I need to initialize that to 0. Good thing we caught that. Okay. Okay, now we have this. Now, what we have to do, one more thing, is that we have to change the changed to false every frame. Because the basic idea that we're doing, just for you guys to understand, let's see that. Let's say this is a button. Let me just draw a button here. Okay, this is a good-looking button. I'm going to type this in different states. Okay, so it starts off as up, and then he presses it, and then he keeps it pressed for a few frames, and then he releases it. Okay, we want to know at these points that it's down, and we want to know at this point that it was pressed, and at this point it was released. What's the game you are making? So we are doing, for just to get started, we're doing a breakout clone. So it's going to start, really simple, just like breakout. But we're going to add to the gameplay a lot, just like I did to the Pong game and release on each channel. We can play that game here. The basic idea is that we have this, simple game, arcade game people used to do, like a Pong or breakout. And that's the first part we're going to do in the gameplay, right? We're finishing this part, and then we're going to do the basic gameplay. Then we can do like crazy gameplay things later on, right? Which is, I did a little bit crazy things in the Pong game, but in the breakout, I really want to do like a lot, just to get better at writing gameplay code. So yeah, it's going to start out as a breakout clone, but hopefully it'll be interesting. But the scope, it is pretty small. I don't want to do I don't want to keep doing this for like years and years and not release the game. The idea of this stream is to show you guys the process of making a game from scratch in C. We know we started this stream with no code whatsoever, and we're typing every piece of code. And hopefully, by the end, after a few streams, I don't want to spend like a lot of time, we'll be able to publish that game. And you guys can download the source code and play around with it, all that good stuff. Okay. Now, we do have, let me just go back to the game. We do have the input being processed correctly by the game. But we do have to reset the change, because that's the thing. This is saying that it's not pressed, so pressed false. We're going to 0. Not pressed, not pressed, 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 not pressed. Okay? This is the is down, actually, not pressed, is down. Is down, false, false, true, 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 false. And the changed tells us if there was a change from the previous state. So there was no change, no change. There was a change, no change, no change, there was a change. So we can see by this combination, we can see, like we can do in the game, the idea is to do things like this. If pressed button left, do this, okay? Or if is down, or if released. We want to have this kind of expressiveness, you know, if you say so, in the game code, and let the platform code worry about these specific details. Okay? So, how are we going to do that? We're going to save these two variables, which is enough for us to know. There was the problem, though, that if, for instance, he presses and releases the game, the button really quickly in one frame, we can probably miss that. So we're going to, we're not going to miss, we're going to probably do a wrong push. So the idea later on, when you do a rough robustness pass, is to change this from a boolean to an integer, and seeing how many times this frame he changed the state. Okay, but we can do this for now. So we just changed this to true. We're already doing this when we do change, right? Actually, if is down is different from the old is down, right? So if there was a change, we set the changed to true. That's the basic idea, right? Just remove this. Okay. The change works like this, but we do have to reset it every frame, right? Because let's say there was a change, right? It was 0, now it's 1, so we set it to true. Now we have to set it to 0 in the beginning of the frame. So when you start processing the frame, I'm going to run through the whole buffer, the whole button count, to all the buttons. And for every button I'm going to set changed to false. Okay, I can even do it like this, just to. Now we shouldn't have any change. Yeah, we don't, right? But now if we do things like if is down and changed, so this is the pressed state, right? Now we should only have, I think it's going to be hard to see. Yeah, it's going to be hard to see because we are like in 1,000 million frames per second right now. So yeah, we can change the position, right? I'm going to do this. I'm going to set the position p equals 20 p, and if it changed, we're going to set p to plus equals 20. So every time I press the button, I'm going to move up a little bit. Yeah, see how weird that was? So yeah, our render does have a problem. No, I guess not. Actually, I should change both these guys, right? So I'm going to do like 30 plus p here. Yeah, so it's not our rendering, it's actually our game code. Okay, so this is pretty cool. Now we can just click to move the, like we're doing now. If I hold, nothing changes. Now if I do the, if I remove this part, if it's down, now if I hold it, you know, it's going to be crazy. Yeah, like this. Okay. Now, as you can imagine, this is pretty weird code to write. We want it to be simple for the game, right? But that's really easy for us to fix. All we have to do, let's see in the platform common, for example. we have like a couple of macros here, define pressed, and we're going to receive the button, and we are going to return this. Okay, pressed button left. Okay, so this is the pressed. And we can also have a released. Okay, if it's not down and changed. And we have a is down, which is just if it's down. Okay, that's the basic things we need to be able to do nice and clean input in our game. See how easy that was? We've been streaming for like 1.5 hours, and we already have like a very basic engine to work on our game, which is like great. The input is great. We can also do these really quickly, the left, right, and up and down, just for the fun of it. I'm also going to do a process button macro here. A process button, and I'm going to receive the VK code, the button. I think that's it. And I'm going to do this. And now I can do like process button VK left, button left. And then I do like right, I do up, and I do down. And then I change here from button left to B, and from VK to VK. Okay. Okay. Let's see if we still have. Okay, yeah, we still have everything. Now we can start actually doing the game code. You know, we can say like player X, right? It's going to start out, let's say 30, and then a player Y. If we press left, player P minus equals 10. It's going to be a blocky movement. For now, right, player plus equals this, and then okay, we're going to do up and down. Player Y minus equals this. Player Y plus equals player X. Okay, so this is going to be player X. This is going to be player Y. This is going to be 30 plus player X. This is going to be 30 plus player Y. Okay, let's just see if we have a basic movement. Okay, and we do have a basic movement. That's pretty cool. Okay. Oh man, that's a lot. That's great. See, even doing like basic things like this movement, we can always think about all these crazy ideas, you know. That's why I like doing it by hand, you know, because, okay, oh, we're just adding every press. Now we can play around with this and change like from pressed to released. And now we have a very weird movement where you have to like first press and then when we release it counts. You can always think about, you know, some game design ideas. Play around with this. Okay. However, there's a problem in our rendering. Before we can actually do our gameplay code, there is a small problem, which is we're not pixel independent. What is that supposed to mean? That means if we have a very small screen, our player moves quite dramatically. See? And if you have like a full screen, like a giant screen here, it takes a long time for him to reach the end of the screen. What we do want is that if we have a small screen, the player is going to be smaller, right? And if you have a huge screen, the player is going to be bigger. So we have to focus on a pixel-independent render. That's the idea. So how are we supposed to do that? And it's not very hard, actually, when you think about it. I'm going to do an internal void, draw Rect. And what I want to do, actually, is receive a vector2. I want to see like an X and a y as floating point variables, because that's what I want the game world to talk about in terms of coordinates. And then the color and a size probably. So we are going to create this vector2 struct. So it's going to be vector2 p, vector2 half size, right? And then we're going to do the color. So the basic thing we're going to do here is convert the units to pixel and call draw rect in pixels. Right? So that's what we have to do here in the draw rect. And in the math, I'm going to create our vector2 class. Well, not class, struct really, but it works pretty much the same. And for now, I'm going to do a union of a anonymous struct of x and y, f32. We don't have f32. We're going to do that as well. And then we're also going to do a array of two guys like this. This is pretty cool, I think, because we can like iterate through that. We can get the number of elements, and we can do all sorts of stuff by doing this union. So they occupy the same space in memory, right? So yeah, that's the basic idea. For that, I'm going to have to go here in the utilities, in the utils, and we're going to do a float will be f32, and we're also going to do f64 for double, but we're not going to use double in this game. Okay, okay, sounds good. Now, in the draw rect, okay, let's just try to compile. Okay, we do compile. So the basic idea we're going to do a couple of operations, right? And you guys will tell me if it'll make sense. First off, we are going to center our coordinate system, because right now our 0, 0 is at the bottom left of the screen. It's right here. Okay, and this is very unintuitive to program. Especially if you want to do like a camera and stuff. What does that mean? I mean, even where is that in terms of coordinates, right? We want the 0, 0 to start at the center. If you want to do a camera, which I do want to do a camera later on when I do like some crazy gameplay ideas, when I do a camera, we can just change that from 0, 0 to whatever the camera position is, which is going to be pretty easy and pretty cool too. So that's the first part we're going to do. We have to center our coordinates. The second thing we want to do is to make it, actually we want to do three things, right? The other thing we want to do, we want to do pixel independent. So basically we want to make our coordinate change based on the width. If you draw, it makes it really easy. So if we have like 100 pixels, right, as a width, and I want to occupy half of the screen, it's going to be like 50 pixels, correct? Okay. Now if I have a 10 pixel screen, I want to occupy half the screen, is going to be 5. So the fewer pixels we have in our screen, we have to decrease, right, the number of the guys, so the number of the conversion. So basically I have to calculate like these values to call this function, right? The basic idea is going to be the p.x minus half size.x. See, because the p here is the center p, and then we go to the half size. So we have to go back the amount, half the amount, right? This end up here, okay? Okay, actually we're going to do step by step, just so we don't, kind of lose ourselves. Okay, yeah, I'm going to do step by step, and this is plus the size. And we also have to do some sort of a conversion or truncation. For now, it's not going to be pixel perfect, but I don't think it really going to matter if the guy plays it like a full screen 1080p monitor. I don't think he will notice the pixel imperfection. We can do like sub-pixel things with the bilinear filtering and stuff. But at this point, we should just use the hardware rendering if it comes to that. Okay, so now we're going to call the draw rect in pixels. Okay, draw rect in pixels, passing all these parameters, x1, y1, color. Okay, let's see what happens. Now, our game, it's not going to store the player position as this. It's going to be a vector2, player p, and then we're going to have a struct player and all that stuff. So we're slowly building up what we need, the tools and the game itself. Okay, so instead of doing player underscore, I'm going to do player dot x. Oh, instead of doing player dot, actually it's player p, right? Player underscore p dot. Okay. Okay. Now instead of calling draw rect in pixels, I'm going to call draw rect. I'm going to pass the player p, and for a size, let's say 10, 10. And the color, let's do green. I like green. Okay. Okay, where's the player? Let's debug that. Not sure. We are passing minus 20, 60. Yeah, because it starts out as 0, 0. So what I'm going to do is I'm going to kind of move him up and to the right a little bit. Just make sure, okay. 260, 260, half size 10, 10. So we're going to start as a 250, 250, 270, 270. Okay, the numbers look good. I'm not sure why I'm not drawing though. Okay, let's try to do the draw rect in pixels here. It's 250, 250, 270, 270. And green. Okay, I did X, yeah. Okay, thanks for catching that, but okay. No, where did I get that wrong? Did X0 Y1? Yes, okay, thank you. See, now I'm starting to reap the benefits of programming on stream because people do catch these errors. And these are the stupid errors, right? No one wants to spend our time debugging things like that. Nice catch, Born Villain. Okay. Now, I'm not moving for some reason. Let me just try compiling again. Okay, let's see. Okay, now I am moving. Okay, so I start off here in the bottom, right? Yeah, human debugger. That's the best kind of debugger, right? It catches all the weird errors that the debugger needs a human to debug with, right? Okay, this is pretty cool. Now, now we have not done anything yet with this, okay? So what we have to do, first off, is just to offset our position by the draw buffer, it's not draw buffer, it's the render buffer width, half width actually, right? So I'm going to convert it to F32 and multiply it by half. So this first step is just to offset the center. Now, if I start the player at 0, 0, which is what I'm doing, I expect him to be exactly in the middle of the screen. See? So that's the first step. Now, if you see, if I do change this, it's still not pixel independent. Okay? Okay, now, the other step, which is changing the position to make it match this that I drew. Okay? So the basic idea is I'm going to multiply that, or divide that actually. I'm going to maybe do some trial and error here. No problem. I'm going to do the half size first, and then we're going to do the position. Half size first. Okay, divided by the width and the height. How often have I done this, by the way? I'm not sure. I started doing this not long ago. Yeah, thanks. But let's see. I did a couple of very weird prototypes that I didn't even publish But the first time I actually did this, understanding what I did, was in this Pong game, Pong in C, and I even open sourced it, but it's not very good. It feels weird. Let's see if there's a date. Okay, so that was September 18, 2018, so it was last year. So it's been like uh, like 8 months of knowing this kind of stuff, which is the point is to practice, because before that, if you see this other game that I did in C++, yes, I am going to this is my itch.io. You can download all the prototype games, but this is the game I actually spent 3.5 years of my life making. The other one, the ones on Steam. So this the brief story is that I did this game, spent 3.5 years building it, and released it in 2017. But by the end, I realized that I didn't actually know how to program. All I did was like hack a few things together to try to make the scripts. And when you're trying to build a game, and a really polished and robust game, and publish that, it's really, really hard to not know what you're doing. So at that time, I was just programming in Unreal using blueprints. No, it wasn't alone. Yeah, no, I didn't do that alone. It was like a 10 people team. I started alone, and if you go to my YouTube channel, I can throw that off too. I'm going to post the live streams on the YouTube later on. You can see on the videos how the game started, and I started all by myself. So this I did by myself in this game. This is kind of the first idea. So it's kind of ugly, and it doesn't feel very nice, right? But the basic idea is there, right? So this I did by myself. I spent 1 year just playing around in Unreal and learning how to program using blueprints and all that stuff, and animation and modeling. Okay, yeah. And then I started doing more complicated levels in Unreal for this game. I built the monsters and the gameplay, and that started to become an interesting game. So at this point, I decided to with the help of my dad, make a team and actually do this real game. So we had for 2 years a company, and we published other games too. We did a VR game, but we didn't publish that on the store. It was like an out-of-home experience. So we had a presentation at a mall that was pretty cool. But we had to close the company after 2 years. So and we hadn't released the game yet. So at this point, I went back on my own to finish the game. So it was kind of a full circle. I started alone, and then had a team, and then finished alone. And the last year or so, or 8 months of development was really, really hard. Not only because of motivation, because I've been doing this for 3 years and I was super tired, but I had no one else to count on in this sense. But it was also hard because I didn't know what I was doing in terms of programming. At this point, when I was porting the game to the PS4, which we also released the game for the PS4, that was pretty cool. PS4 Iliosis Hunt, which is the name of the game. Yeah, you can see our page on PlayStation, and it's pretty cheap actually. You can get it for a few bucks. Yeah, see, pretty cool. So when I was doing the port, I had to do it in C++, and I didn't actually know C++ at that time. So that was really weird. I had to really Google everything, and there was a point where I had to upgrade the Unreal version to get the latest version of the PS4 SDK. But Fmod, which is the middleware we used for the audio, hadn't updated yet. But we had to start certification process in the PS4 because the SDK expired, right? Was going to expire. So I contacted people at this game I used Unreal. I used Unreal Engine 4. So at this point, I had no idea actually how to write games from scratch when I did this game. I just looked for tutorials and started doing that. If you go to my YouTube page, you'll see the process was pretty interesting. I started modeling the character, and then okay, how do I move him? Okay, now how do I make him shoot? How do I add enemies? It was a very slow process in the beginning, but these engines are good at making progress tangible, right? So I managed to build this game. If you see what I did alone before people came along, was a lot of things, and it wasn't like experienced people either. We just it was like a few students that we want to come together to finish the game. That was pretty cool. And by having the prototype, yeah, I also did the models and textures. In the final game, we actually had people who could do a better job than I did. to build the characters and environments and all that stuff. Yeah, it was great. It was a great experience, Morpheus. It was great because by knowing all the process, even though people came along and did a better version of everything I did before, if you compare with my version of the game, you can see on YouTube my yeah, you can see the other videos. Like I did this character and I made him. If you see the final results, people were like, people who had a lot more experience than me and a lot more interest in those areas managed to do a better job. But because I had been doing this for a few months and know a little bit about it, I could not only direct him better, but I could make the game more cohesive, and that's I think a very important thing. When the programmer doesn't understand or doesn't care about design or art, the game really suffers, and vice versa. So if the artists just create crazy art and doesn't care about, it's very evident when you see like professional, big developers like Jonathan Blow saying about the braid art and how he had a really hard time making it not control the gameplay in the sense that it shouldn't focus too much attention of the player. You see that it's a very thin balance between being able to create good art for the game or in good art. You see, things are different. So yeah, it was a great experience to do that. But at the end, I was like, oh my god, I can't really program. I had a hard time shipping the game because I didn't actually know what I was doing. When I went to the C++ part of the Unreal Engine, I was just hacking things. I just Googled and copied code from one place to another. I had no idea what I was doing. So when I finished the game in 2017, I started to learn programming. So I spent a few months, learning C++, and then I started applying C++ inside Unreal, which I had a lot of had a lot of experience with. Let's put it that way. And then I had all these problems with C++ that it's a very complicated and big mess. It takes a long time to compile, and Unreal crashes, and I'm not sure, so I have to run the debug build. It's crazy. So in order to avoid that, also because I had an opportunity to work outside the games industry, I took that opportunity. So my day job's not related to games. So I took, okay, since games going to be a hobby for now, I'm going to start exploring other things like building games from scratch and things that I really, really enjoy. So I fell in love with writing games in C. So at this point, I started building these games. So this game I built using C++, but I didn't actually understand much of it. I was still like copying a lot of tutorials. Let's see, when was that? That was a little bit over a year ago, a year and a month ago, the beginning of last year. So by the end of the last year, I was able to make games like Pong from scratch. And I did a lot. I did like Space Invaders, and I helped my friends. I taught them how to do it. So I did practice a lot. So at this point, I was thinking, okay, I think I'm comfortable doing that on stream, and it's hard. I'll have to get used to that. But I think I'm learning a lot. English too, because English is not my first language, and talking in English for like hours and hours, it's I'm also gathering a lot of experience in that as well. That's gonna be fun. So let's see what we have if we try to attach our half size to width and height. Okay. What made you switch from C++? Okay, so yeah, I did C++ for a long time. A long time, like a few months. I'm very young, so when I say a long time, you can imagine like a short amount of time, right? And I realized that I was using pretty much just C in C++. I wasn't using templates, I wasn't using classes, I wasn't using all these crazy things that C++ give you. And I think C was a lot cleaner in terms of like, I could just quickly see the code and know what's doing. I don't have to get, okay, what does that do? What's the reference versus a pointer? No, it's very easy, the rules. I can talk about the rules of C really quickly, and the rest is how you use the rules, and that's what appealing to me. It's kind of like a game. Like you learn the basic mechanics, but the interesting part is how the mechanics combine, right? So I think that's why I like C a lot. But I also have in my plan to learn a little bit more about C++, because people in the industry use C++, right? There's no escape. Because the more complex the game is, the more features you need, like namespaces and things like that. Especially if you have a big team building a game. But yeah, so for this scale of game we're building in this stream, C is fine, and I love it because it's simple. I don't have to think too much about what feature of the language I'm going to use, right? If we get to the point where we're building more complex games, yeah, you are a C fanboy? Yeah, C is great. Yeah, I really like it. Especially, although there are a couple things in C++ that I wish there were in C. Like, I think everybody who programmed in C wished there were a feature or two. But I don't think it's worth, using C++, at least for now. I like to get the hang of things, before doing more advanced things. So yeah, maybe at some point when we start doing more advanced games on the stream, that'll be fun. We can start doing this on C++. But I don't know. I like C. Let's see now. I don't know what's gonna happen exactly. So we have a tiny square. I don't know if you can see. And if we increase, if we increase the size, it actually decreases, right? So we probably inverted that. Yeah, the bigger the size, the more pixels we need. Yeah, I was kind of crazy. Okay, yeah, now we have a huge square. Let's see, yeah. I'll do a constant scale here, just to have like a reference for our unit system. Let's call it that. So I'm also going to offset it by the scale. Not offset, I mean change the scale, okay. Okay, now we have a very small rectangle, and now we're having a bigger one. It's not 100%. I could cheat for the other code because I'm not a big math guy, in case you haven't seen, right? But what I am going to do is I'm going to offset the P after I offset it in the scale. I also have to do that in P, right? Because this is in pixels, right? We're moving half the screen width to the side. If we do that before we change the scale of the P, we're going to do that in our units system, which is going to be a lot more. So if you offset like 1,000 units to the side, it's going to be like a lot more than just offsetting, in pixels. That's the plan. Okay. It's a little bit weird. If I make it full screen, I don't know if you guys can see, but we do have a little bit of a guy here. So I don't think it's entirely wrong. I just think the scale is a bit off. Let's see. Okay, so this is the base size. Let's see how small it gets. Okay, it gets decently small. And if you go larger, it goes larger. Okay, so that's the basic idea. We do have the basic idea right. But there's a problem, which is a small error. And the way we choose to resolve this error is going to be interesting, right? We can't make the x dependent on the width and the y on the height, because if we have like a super wide display, it makes everything flatter and squashed and things, right? But if you have a super tall display, it makes it thin. So we have to stick with one. And the question is, which one will we stick? Because we could stick with a random one. Let's say the width. Okay, and then let's see the result. The result is we have like a square. Oh, wait a minute, that was wrong. I also have to change here. Okay. Okay. We got offset by the position, but don't worry about that. What I want to show you is that if you choose the width, for example, if I change the height, the size is not going to change. So the taller the display, the more screen real estate, let's call it that, I have, right? So if I make it super tall, I get more view up here. But if I change the width here, it gets smaller. Okay, so this is the difference. If we change from width to height, the opposite will happen. So we'll have if we change the height, it's going to get smaller, right? And if we change the width, nothing's going to happen. The question is, which one should we choose? The more intuitive thing is to keep it like this, right? Because if people have like super wide displays, they can see more instead of being cropped. However, I do think a more interesting solution is to take the 16:9 aspect ratio as a standard and see, well, if I'm wider than that, I should gain real estate. But if I'm taller than that, I should gain real estate too. So what I'm going to do is I'm going to create a variable called, I don't know, let's call it aspect multiplier, which is a really bad name, honestly, but let's just do it for now. And okay, what I'm going to do is I'm going to change render buffer dot height to aspect multiplier. Okay. Now, illegal indirection. Okay, aspect multiplier. Okay, so nothing's changed, right? Except I can play around with this. So the idea is I'm going to use the height, but if the width divided by the height, right? Yes. Okay, so if the width divided by the height is less than 1.77, which is the normal aspect ratio, let's call it the 16:9, I will change the base of the aspect multiplier to the width. So hopefully you guys will understand. Let me show you what I mean in the game. So this is the base thing. If I were to, this is 16:9, right? This is 1280 by 720. If I were to change the height, the width a little bit, okay, nothing happens. I think I may have messed. Yeah, if I make it, yeah, it's the other way around. I will start off with the width and change it to the height. Okay. Let me show you. If I change the, yes, if I gain width, I actually gain real estate. It's getting off the screen because the center is wrong, right? But that's the basic idea. We are getting more space when we do that, okay? And if you do this, we also gain more space. Now in the height, okay? Yes, it gets smaller. That's pretty cool. However, there's a point in which we kind of snap, right? You see the difference here? That's because we changed from using the height to the width, and they have a 1.77 fraction of difference. So if we change the scale in this case to also, we don't need to change the scale. I'm going to change it here directly. So if we offset this by this guy, I think I have to divide it though. Hopefully, yes, I'll get a smooth transition. So at this point, if I increase the width, I get more stuff. Actually, it was right. Well, and here, if I change the height, I'll get more real estate, okay? So this is basically what we want. But let me fix this position thing. Yeah, this one I wasn't supposed to change. This one was really supposed to be the render buffer width and render buffer height. So this is the part of the programming that I need to get more familiar with, all these math things. But okay, that's it. Now it's centered. If I were to change, yes, make it flatter, I'm losing space, right? Because if I have a taller device, for instance, I'll be able to gain that. I don't think it's right. Let's see. No, it's not right. See that this is increasing size? Yes. In width? It was right, I suppose. So this is the height, and this is the width. I'll review the code and what I mean just for you guys to understand. So this is the base game. This is the player size of the player. Let's say that I'm playing on a very wide display. What I want to do is that to keep the player, maybe I should draw more random things. So okay, let me print screen. Okay. So let's say that I have more things. I have a tree over here. Okay. If I have a wider display like this, what I want is be able to see a new tree. I don't want to make everything bigger like this and push that tree to the side. I don't want to do that. I want to see more. This in the case that we are wider than 16:9. However, if we have like a 16:10 display, in this case we want to see more things on the top and the bottom. So if I have a wider display, see, the size doesn't change. All it changes is the position, right? So I get more things on this side and on this other side as well. If I do that vertically, but if I do decrease the size, I do see the change, right? Okay. And the vertical is the same thing, right? Here I am gaining space, and here I'm changing the actual size. Hopefully that was clear. Let's just make it more pixel independent, and now so that we can write, gameplay code, not worrying about the aspect ratio. Okay. What I'm going to do is I'm going to now make the final thing we need. One last thing that I forgot to write here, but it's time. Time. Okay. We need to know how much time passed between last frame and this frame, so we could do proper gameplay, let's say frame rate independent movement. So this is the problem we have. If I change here from pressed to is down, this is going to, first of all, I'm going to be super fast, right? Yeah, super fast. But if I make it full screen, I don't know if you guys can see, I'm not as fast because I have to process more pixels, so a frame takes longer. So I'm doing this fewer times per second, right? But in this case, I'm too small, right? Oh, now I was so fast that I actually got off the screen. So that's the problem. I'm super fast here. If I make it smaller, see, I'm going really, really fast. So the idea, and this is the same when you use like a commercial engine too, is to receive like a delta time here, and then you multiply this by the delta time. Delta means the amount of time that passed since last frame, and since this unit is what we want to do actually is we want to do units per second, correct? So we have units. So the delta time is how many seconds passed since last frame. So if we're doing this every frame, and we do this, and we multiply that by the 1 over the seconds that passed, I'm basically going to get this. I'm going to get the units per frame. So 20 units per frame. So this makes it very clear. Makes it very easy, to change gameplay related things. Okay. So how are we going to do that? We're going to go back in the platform code, and well, if you want to cheat, but it's not going to work, right? But just for us to get a sense of it, if we have like a DT here, and we set to 0.016, which is like 60 frames per second, and we pass that to the simulate game, now it's slower, but still not independent of the frame rate, right? So this is pretty slow, as you guys can see. If I make it very small, see that I'm really faster in my movement, and now I'm very slow. I'm not entirely convinced. Yeah, the transition didn't work in terms of the rendering. Maybe I have to define that by 1.77. Yeah, I think now it's correct. Yeah, okay. So now we have to actually change this number, correct? How are we going to do that? In the Windows, and it's the same thing when you use a framework like SDL, we're gonna have to call these things. They have a function called query performance counter. Okay, and this is pretty much it. We pass what they call a large integer. We pass a pointer to that, and then they return the time in CPU clock cycles, approximately, right? With 1 nanosecond of precision. Not a nanosecond, a microsecond of precision. And then we can compare how much time passed from the previous frame to this frame, and now we know how much time the last frame took. And that there's a great talk of John Bolt talking about frame rate independence and how you really shouldn't use the last frame's time as the current frame's projected time, because maybe last frame was low just because, I don't know, something happened. there was a Windows update download or something like that. We should actually just project to a target delta time, and if we have for several frames been behind that, we change that. But that's more advanced platform stuff. We're not going to do now. For now, all we have to do is after we finish our frame, we're going to get the frame time. Okay, so it's a large integer, and we're going to call this current counter, and we're going to pass a pointer to that. Okay, okay, and then we also have to have a last counter, right? A last counter is the one that was last frame. Last counter, and now it's going to be a current counter. Okay, and we're going to start off our loop here, getting the time, right? Last counter, last counter. So you start off, we get the time, and every time the frame ends, we're going to do. Why make a game in C language? Yeah, C++ is pretty much like C, at least in the terms that I use it. But I should probably use C++ in the sense that most people in the games industry use C++. However, I think it's very complicated. It's more complicated than it needs to be, in my opinion. So I like C better. And since one of the goals of this stream is just to have fun, I decided to use C. If the game, not this game, if we finish this game, because this game is pretty simple, we can do it in C pretty easily. But if we start doing more complicated games and we see that we need more features, language features, maybe we should do maybe I should do a C++, I don't know, live stream where we change things stuff. But yeah, I think C is cleaner, so we can quickly see the code and realize, okay, this do this. I can quickly understand my mind. In C++, at least for me, that I don't have much experience with modern C++, I see a lot of different things, and I have to think, okay, this, what does that mean, and stuff. And the compiler time is longer, so I don't know. I just like C; it's simpler. I don't know, but yeah, a lot of people use C++. And if I, wasn't doing this for more of a commercial objective, like to make it to learn more experience to get a job and things like that, I suppose I should be using C++. But it's not a very big difference. You'll be able to understand the game pretty easily, making our game in C++. But that's pretty cool. Doing low-level things I like. And yeah, C is really fast. I really like it. And simple too. Okay, so the DT, we're going to drop here on top when we first query. So the first frame, since we don't know, for now we're going to assume it's 60 frames. But when we do the platform robustness pass, we're going to actually query the Windows to see, tell me the refresh rate monitor of this guy. Okay, then we can do a target DT. We also have to do that for the audio system, which is going to run in parallel, another thread. Okay. So now we get the query performance counter. We have the difference right here, right? We can do one minus the other. However, they are in a crazy unit. They are in a, I don't know if it explicitly says what unit is this. Yeah, it's a performance counter unit, right? So what we have to do is we have to transform that to seconds. In order to do that, all we have to do is a query performance frequency. This frequency guy tells us kind of a baseline for the query performance things. Yeah, it's going to be great, threaded programming. And you see that it's not very complicated once you get the hang of it. Remove C++ on it. Yeah, I agree. Drink vodka, play Dotka. Nice name. Yeah, I do like good old C in terms of features. And it's going to be pretty cool, Morpheus. So if you want to follow along, when you do audio, we're going to do threaded audio, and that's pretty cool. Because threading has this, I don't know, mysticism behind it. Like, oh, we have to thread because everything's super slow. When you program C, you see that things are not very slow, but sometimes you do have to thread, and you do want to do that as a performance thing, or just because you want to run, you want to do this with a window, and you don't want the audio to be all messed up, right? This is also interesting, another benefit of using threaded audio. And if you miss a frame rate, the audio it's not going to clip, right? There's several benefits. And once you get off this mysticism behind threaded things, that people usually have, like, oh, complicated systems, oh, we have to use job system for that and for that, mutexes all over the place. We can do like a very simple threaded system, but a very effective one. So that's what I'm aiming at for this project. Later on, we can do like threaded rendering with more complex things. But yeah, one step at a time. That's pretty cool. I'm currently using the thread section of the book, Advanced Programming in the Unix Environment. It's hard to understand if you've never done thread programming. Yeah, it could be very hard to understand. I suggest Handmade Hero is where I learned to actually, you know, all of those more advanced. Handmadehero.org. I'm going to drop here in the chat. I don't remember threading. Let's see. Threaded. Yeah. Yeah, around day 122, episode 122 of Handmade Hero. He teaches about multi-threading, and it's great. He goes really smoothly, and then he builds a full-on job system in a few episodes. We're not going to do that yet, that advanced, for this game at least. That's why I like this series in terms of getting our feet wet instead of doing all this complex stuff. But I think it's going to be way better for you to watch those videos instead of reading, I don't know, Unix environment books. I don't know, I haven't read that book, so I'm not sure. But this is where I learned, and I don't know, it stuck pretty well. It stuck pretty well? Yeah, it got pretty well in my head, okay? Yeah, but for now, all we have to do is finish this. So we're going to use the query performance frequency. Kind of a query performance frequency in the MSDN. Let's see, okay. And this function, yeah, you say the book's amazing. I will take a look at this book. Yeah, and complex topics like threading and stuff can get really out of hand quickly. So yeah, it really depends on how they tackled it. But if you say it's good, yeah, that's great. Yeah, I did read a book called Game Engine Architecture. That's a classic one, right? Game Engine Architecture. The guy who wrote this book is the lead engine guy in Naughty Dog. So yeah, it's a pretty big book. It has over 1,000 pages, but it's very much worth it. Yeah, I read it twice, honestly. Yeah, I don't like too much the practical side. You know, when he shows code and things like that. I think that's too complicated. At least for the level when I was reading the book. However, the theory where he explains every topic, it's fantastic. You know, he's a really great programmer. So it's a great book. Yeah. So this is the basic thing. If we call this function query performance frequency, here, let's say, yeah, in the beginning, and we pass another large integer, I'm going to call this frequency counter, and pass a pointer to that. Now what we can do is we can divide these guys by the frequency counter, and we get the seconds, right? Because the frequency counter is the amount of counts, let's say the cycles, the CPU clocks per second, right? And we have the amount of CPU clocks because we just got it here, right? So what we are going to do is dt equals, actually I'm going to call this last dt because that's the last frame's dt. Maybe we should have a target dt later on, but for now let's just use the last dt. Last dt is going to be equal to the current counter dot quad part. That's how this large integer is structured. Minus last counter quad part. This divided by, and I'm going to do the division in integer because has a lot of it's a very wide integer, right? Divided by the performance, the frequency counter quad part, and now I'm going to convert that to float. Okay. So in the first frame, we should have the last dt. Okay, I'm going to call this last dt, and then here I'm going to pass last dt. Okay. So in the first frame, if we run our build here in the game, okay, let's just see here. Where's the simulate game? Here it is. In the first time, the frame rate is the one we set up. It's 0.016. That's a sixth, a 60. Yeah, that's 1 divided by 60. So in terms of seconds, right? Okay, but if we run this for a time and then we breakpoint this, see the numbers. I think it's wrong. It's 0, right? We have to debug that. It's supposed to be very small, but not 0. Why do you use this IDE for Coder? I use it for just text editing. I think it's great for fast iterative programming workflow, I suppose. One of the reasons I really like it is this ghost indentation, virtual indentation. So if I open like a bracket here, it automatically indents everything below it. And I think this is really great, so I don't have to worry at all about indenting code, which I think is just a giant waste of time. And it works great. Like if I do an if here, it will indent this line, and I can put it like this, and then it will not indent the other line. It's pretty smart. You know, I can do like indent these 2 lines. So this is the main reason I really like this indentation. It also works great right off the bat with the way I do builds. I created in the beginning of the stream this build.bat file that just runs the CL compiler. And if I press Alt M, it automatically looks for the build and runs it. So yeah, it's pretty, and it's fast. Like it's really fast, really good. But for debugging, I use Visual Studio because I could use another debugger. Like there's another one, I think it's Remedy VD, I think, that is getting pretty good. I should probably try that out. But since I have to use Visual Studio for compiling the game, I might as well use it to debug, right? But note that I'm not compiling a project here. I didn't create a project inside Visual Studio. I just literally, use a command line argument here to send my file for Visual Studio to compile. So I use it because I think it's pretty fast in terms of work, and it's free too. It's I showed it previously in the stream. It's on itch.io. If you search for Coder on itch.io, you can download the demo, which is the version I'm using, which is a fully featured. It's pretty cool. And if you want to pay, it's pretty cheap too. But if you pay, I think it's $12 or $15, you have the full customization layer in C++, I suppose, or C, I'm not sure. And then you can change that and do whatever you want. People have done all sorts of crazy things with this editor. But I really like it, the way it is right off the bat. Okay, so we are almost done. We have to debug this small problem. Let's see here. The quad part is kind of a reasonable number, I suppose. This guy is greater. Yeah, I suppose. If I subtract the 2, I'm going to show here the watch window. If I subtract the 2, yeah, I got this number. Sounds good. And the frequency, this guy. Okay. Yeah, I suppose I have to do this in float. If I divide these guys by this guy, yeah, I have 0 because it's a small number. Okay, so I'm going to do this in float, the division. I'm going to do the subtraction in int and the division in float. So I might as well store this guy as a float, right? I'm going to do a frequency counter. I'm going to store this as a float. And I don't have to convert everything to a float. Okay, this looks good. Okay. Illegal for union. Oh yeah, because I have to change the type here. Okay. Frequency counter. I'm gonna call this frequency counter large, and then I'm gonna create f32 frequency counter equals f32 frequency counter large dot quad part. Okay. No, not this quad part. Okay. Now this should be a more reasonable number. Let's see. LASDT. Okay. Now our LASDT is 0.003. That's more interesting, right? Now if we try, now we're really slow, right? Because we're in real units, I suppose, for now. So if I go to the game, I'm gonna create a variable like speed. gonna set it to 100, maybe a little bit more, and I'm gonna change 20 to speed. Okay. Now I should now have, wow, it's still too slow. Maybe I should change the scale. I'll have the guy be 1 by 1, and in our rendering I'm gonna change the scale. Let's see. Okay, that's more like it. Okay, this is not a perfect movement system yet, because I think I'm going to use the mouse actually to make the actual gameplay. But for now it will work just for a test of our systems. Now let's test. A very small screen should still be okay. It's approximately the same speed. In a super large screen, it's still the same. Okay, that was a lot, right? There's like 2.5 hours of streaming. So I'm going to wrap up this stream. And the next stream, which is probably going to be tomorrow, we're going to do the gameplay part. So if I go back to this plan, I can even type this in the game here. I'm going to type a to-do here. To-do. I'm going to do it. Okay. Initial platform layer. Not layer. Which is window, rendering, input, time. That's about it. And then we have to do basic gameplay. That's for next time. We're already going to start doing our basic game. See how easy it is to get a small engine started? And that's because we wrote all the code. Next time, if you were to do another game, and we can start off copying things from this, not even getting this guy, just copying code. We're going to do like way faster. Basic gameplay is going to be the breakout thing. And then we're going to do an engine improvement. Maybe we're going to do, we are going to do audio, threading, and let's see what else. Bitmaps maybe for menus? I'm not sure. This is going to be like a live, let's see, a live iterative process. We're not going to finish the basic gameplay to start doing that. We're going to do all of them in parallel. But the idea is we're going to do a little bit of gameplay, a little bit more engine. Then we're going to do like, let's say, gameplay exploration, initial gameplay exploration. Then we're going to do the more gameplay exploration. Okay, and then we're going to do the polish pass, both in the engine and game. Okay, so that's the basic things. We already did the first, which is the initial platform layer. So let me just show you guys what we have. When we play the game, we have a window, and we have a little guy that moves if we use the arrow keys. We should probably also do the WSD keys. Yeah, okay. And this, we create our software render, right? It's pixel independent, so if we make the window really small, it works great. If we make it really wide, it still works great. We can have more view. If we make it really tall, we have more view up and down. That was a pretty cool thing we did in the rendering. If we do like a pseudo full screen, it will still work great in terms of rendering and in terms of time, because we are running really slowly. Not really slow. If I make it like full screen on my display here, and I pause here, let's see, the DT is like 0.019. Okay. And if I do like a very small display and pause it here, the DT is 0.0003. All right. So we do have a huge difference because of our rendering, and still the speed is the same and the rendering is good. So is there any question regarding what we did in this first stream? What we can do now is just a quick code review, and I'm going to post this code on itch.io now. If you guys are interested to download it, you can download it for free, and what we did today, and play around. Hopefully you guys understood what we did, and you can improve. You can already start building your own games with this, right? This game.c file, we can start doing a lot of cool stuff, right? That's what we're going to do the next time, start doing gameplay. This basic setup we did. But it's pretty cool. In terms of API design, I think it's really nice. You know, nice to get the input, nice to draw things. The game doesn't have to worry about anything at all. Just get the input and start doing gameplay stuff. That's what we need. Okay, so let's see. The basic idea, so we have one compilation unit. So we compile just one file, which is this win32 dot, let me just close this one. Yeah, win32 platform.c. This is the main file. So it includes all other files as a pure text. So utilities we did for our types, math for our vectors, platform common for the button and stuff. And then we start doing window stuff. We had to do this window callback that closes the window, plays around with the size. We did we main, right? Which is the Windows entry point. First thing we did was create a window. That was pretty cool, pretty easy. And then we started adding things, like now we added input, now we added the performance counter. And then the basic idea for our game loop is input, and each platform can do its own input, in its own way, right? We also had this nice interface to do more input. And simulate the game. Now, this is the idea of the game as a service, right? We just say, okay, the platform is the software, but it says, okay, game, now you can do its own thing, and then the game does its own thing, right? And then our rendering is just to tell Windows with this stretch di bits function to use our pixels, our buffer here, to draw on the screen. And then we get the frame time and just a quick note. If we run the game and we can see the process running, it's using one core at its max speed here. Okay. Here, see, it's using like 10%, which is like going all crazy, on the score, because we're not sleeping or anything, right? As soon as we say to the Windows API to draw this, we start getting the input again. In the more robustness pass in the engine, we are going to sleep here, right? There's a ton of stuff to do, but we are going to do the game next time. Okay, so I hope you enjoyed this. If you do, be sure to follow me. I'm going to share a lot of links, right? Now, okay, you can follow me on Twitch, right? Right now, you can follow me on Twitch. So you can. It's going to be a weird thing. Follow me on Twitch, so you see when I stream next time. It's probably going to be tomorrow, but who knows? Well, you can also follow me on YouTube, which is youtube.com/DanZaydan. And I'm going to post all the streams on YouTube if you want to rewatch it. And if you want to get the game, which is going to be free, you can go on itch.io, danzaydan.com, danzaydan.itch.io. And I haven't created it yet, but I'm going to create it now. And you can download it and have fun, with the version we have now. And if you want to expand on it, great. It's whatever you want to do with it, But next time we're going to focus on the gameplay, and that's going to be fun. So I hope to see you next time. Hope you enjoyed it and maybe learned a couple things. And I'll see you then.